Kia ora, here's question 3C from last year's Level 2 Calculus paper. So I'm doing just this one little video in here because the excellence question in here is going to take quite a while, so this will be very short. So a school is selling tickets for its drama production, and the revenue can be modelled by this function here. So we haven't got y and x, we've got r and p. So p is going to work like x in here. Use calculus to find the maximum possible revenue. So the maximum revenue will be when we've got a turning point, and so we've got r dash of p is equal to 0. So we're going to differentiate, solve that derivative equal to 0, and that's going to give us a price, and then we're going to substitute it back in to get the maximum possible revenue. Okay, so let's get on with it. So r of p we can't differentiate in this form. We have to expand those brackets out first. So we get 40 times 29p, so 1160p minus 80p squared. And now it's straightforward to differentiate. The first derivative is, oops, we've lost a p in there, haven't we? There we go. So it should be 1160 minus 160p, and we need that to equal 0. Right, so 160p is 1160, or 1160. P is equal to 1160 over 160, which gives us P, the price of the tickets, of $7.25. So we should probably write that down in dollars and cents. So ticket price should be $7.25 to maximize revenue. And now we're going to substitute that back in. So R at $7.25 is equal to 40 times 7.25 times 29 minus 2 times 7.25. You could substitute this into our expanded out version, it won't make any difference. And that gives me 290 times 1450 for this bit in here. So this bit is the 290, this is the 1450, and that gives me maximum possible revenue of $4,205. So that's all there is to it for that one. I think that's a merit question. So again, the big idea here is that whenever we're working with functions, if we want to find the maximum, we find the first derivative and we set that equal to 0. Now we weren't asked to show that it's a maximum, but let's just check how we would do that, just because this video is so short. This is my first derivative, and I can use the second derivative test very easily here. And that's because the second derivative, r dash dash of p, is really easy. It's negative 160. And that's negative for any value of p. So if we work out the second derivative at 7.25, we'll get negative 160, which is less than 0. Therefore, we've found a maximum, not a minimum. But as I said, you weren't asked to do that, but that's one of the ways you could do that. Remember, if you've watched the earlier video from question 2, I think it was 2D or 2E, there are 3 ways to justify why something is a maximum or a minimum. And the second derivative test is one of them.